All right.
Great. So welcome to the ADSA Data Science Education SIG meeting, everyone. We're hearing from Stephanie Hicks today about the Open Case Studies project. And I am going to hand this over directly to Stephanie, who can take control of the screen, and we'll go from there.
Thank you. All right, what do you guys see?
We see you.
And the screen.
And the slides, yep.
Okay, perfect. So I had really no idea what to prepare for in terms of the audience, so I'm happy to skip over a lot of this because this is a community of people that I know, but maybe it's useful to others. All right, so this is a project that I've been working on for 2 years now, and it's one that I'm heavily invested in because my work kind of sits at the nexus of applications, so specifically genomics mostly, but broadly data science applications, and then data science education. And so when I teach my data science course, I'm interested in trying to bring in applications more and more into the classroom. And the way that I have been doing that over the last few years, both as a teaching assistant and now a full faculty member, is to really bring in real world challenges into the classroom. And so historically, people have always tried to produce content in the classroom that's very simple, using simple case study examples that never violate any assumptions. The data are always clean and perfect and show you exactly what you want. But in the real world, that's never really the case. And so my goal here is to bring in that messy aspect, that real world aspect into the classroom with the project. All right, so a little bit about me. My bachelor's is in mathematics. I have a PhD in statistics. I did my postdoc in Boston, and now I'm a professor, an assistant professor in the Department of Biostatistics at Hopkins. And I have, as I mentioned, like broad interests in statistics, genomics, data science. And because I'm in a school of public health, but also because public health is important, I have a doppelganger named Puppet Stephanie, and Puppet Stephanie and I are being used to create children's videos to teach students, young children, about data science, because nobody wants to hear about data science from an adult. If you're a child, you'd much rather hear it from a puppet. So I'm really excited about that. That is unfortunately on hiatus. My puppet is in my office and I have no idea what I'll be able to get back into my office, but anyways, okay. So I motivate this with data science as being a really big problem. So here are the number of data science job postings and searches per 1 million on Indeed.com across years from 2015 to 2019. And the purple are the postings. So these are the companies that are interested in hiring individuals. And then the blue are the people who are searching for those jobs. And what that means, if you translate that in an economic sense, is that this is the demand. So this is what's in demand in terms of people needing to be filling roles to analyze data. And this is the supply. And so we have a shortage. And so the goal here is to try and fill that shortage by making data science education more efficient and more scalable. So we do that in the data science lab. So I'm involved in an organization called the Johns Hopkins Data Science Lab. Our mission really is to make data science accessible to the entire world. It's a very broad statement. We have some specific goals on how we do that. And one way we do that is teach people how to design, collect, interpret, interact with data. We also are trying to build support environments for people at Hopkins who use data creatively. Oh, go ahead. Hello? Was there a question? Nope.
If you're not speaking, go ahead and mute your situation. Yep, thanks.
Okay. And yeah, so we do this in a variety of ways. I'm going to focus just on this top bullet point today, and I'm happy to talk about other bullet points if anybody wants to at the end. Okay. So I'm going to talk about teaching how to design, collect, and interpret and interact with data. Since I'm in a school of public health, I thought I would highlight one initiative that our school is focused on. It's called the Bloomberg American Health Initiative. It has a focus of addressing 5 public health challenges: addiction and overdose, environmental challenges, obesity, risks to adolescent health, and violence. And I highlight this because I received funding specifically from the Bloomberg Health Initiative to develop what I will call 10 case studies, and I'll explain what I mean by a case study in a minute. But these case studies that have been funded are focused on public health challenges. However, I just want to state that the concept of case studies are broadly applicable to any real world challenge. It could be politics, it could be biology, it could be anything. But the projects that are currently funded are focused on public health. Okay, so for the rest of the talk, I'm just going to talk about these case studies now. You may ask, what is a case study? A case study is a hands-on data analysis that's addressing a real-world challenge. And I'm going to give a lot of examples and go into great detail about what I mean by that. The project itself as a whole is called Open Case Studies, and it can be thought of as really an educational resource filled of case studies. And the goal there is to teach students how to effectively analyze and solve real-world challenges. So again, this concept of bringing in the problem and the real-world challenge into the classroom, and then teaching students how to address that challenge with data and data science skills. The individuals who are involved in this project are 5 faculty inside of our department: me, Carrie Wright, Lee Yeager, and Margaret Taub, and John Michelli. Carrie actually was brought in with the funding from Bloomberg Philanthropy, so I was really excited to have her join, and she's doing a lot of the heavy lifting related to these 10 case studies that I'm going to talk about. But we're all involved in the project and happy to talk more about how it works. Okay, so let's dive into one case study to try and motivate this project. So this was a paper published in 2019 in Nature. And for a long time, it's been thought that urban areas are actually the driving reason for increasing obesity over time. And this paper came out in 2019 and argued the opposite. They actually showed that rural areas are the fastest growing areas for increasing obesity. And they actually show that women have increasing obesity rates much higher or much greater than men do. So we thought this would be a really great case study to build, because it's an interesting question about trying to educate others about increasing obesity rates across the world, and specifically this surprise fact that rural areas are growing much faster than urban areas. And you may ask, why do you care about that? Well, because that means maybe public health policy needs to be built around addressing this in rural areas as opposed to focusing in urban areas. So we're educating students. The goal would be to educate students about this public health challenge, but at the same time, teach them about how to analyze this data. Does that make sense? All right. So if you go to look at the data itself, the data are stored in a PDF. And if you've ever worked with data to PDF, you'll know it's very difficult and very frustrating to use. I mean, it's almost like so beautiful that it makes you want to cry. And the PDF is like 60 pages long. You have countries here along the rows. There are standardized mean BMI estimates in 1985 here on the left, and in 2017 on the right, stratified by men and women, stratified by at the national level for the country, and then stratified between rural and urban areas in the country. And so the goal here would be, first, slightly panic when you realize like how hard this is. It's not like you can just like copy and paste this in Excel and hope that like all the formatting works out. I mean, it's a little bit terrifying. So on top of that, you've got missing data. So some of these, you've got standardized BMI, age standardized BMI rates that are missing entirely. So you've got NAs to deal with. But the goal here is to be able to teach students easily and feel confident in being able to take data from a PDF and put it into some kind of programming language. So that's kind of the first step in building the case study. So you introduce the concept of what's the problem that we're trying to address. So here the problem is we want to investigate increasing obesity rates in rural and urban regions across time. And to be able to do that, we have to the first step is to talk about the data and getting it into our Python. And so teaching students how to do that, I think the argument that I'm making should be brought into the classroom, because that is a messy aspect of data analysis and data science that everybody does whenever you're analyzing data, and making that part of the classroom experience more closely mimics what a data scientist would experience in his or her job. So now I'm showing you a screenshot of the top of the case study. So here I'm using the R programming language, and I'm showing you an R markdown, a knitted R markdown. And at the top of the case study here on the left, you see there's a table of contents, and it's got something called motivation. The thing that's highlighted is motivation. Every case study that we build starts with a motivating image. And I got this idea from Mina Satankaya Rundle. She gave a fantastic lecture at Harvard, I want to say it was last year, the Harvard Pickard Award. And in that talk, she talked about how you should let the students eat cake first. And she introduces this concept of, if I'm a chef and I'm teaching other people about how to build a pineapple upside down cake, if I just tell you that, if I say, okay, today we're going to build a pineapple upside down cake, and I give you flour, sugar, pineapple, and whatever else is in a baking powder. If I give you those ingredients, if you've never seen a pineapple upside down cake and you have no concept of what that is, it's very hard to imagine where you're going. Now, if I say, for example, I'm going to show you a picture of a pineapple upside down cake, then you have a sense of, okay, now I've got these ingredients and I kind of see where I'm going. I don't necessarily know exactly how I'm going to get from A to B or A to the end, but I have a sense of maybe the cake is going to be upside down at some point and the pineapples have to be here and so forth. Now, if I then not only show you a picture of it, but then I let you taste it, for example, then you have like a strong sense of where you're going. And so the idea is every case study starts with this motivating image, and this image is what is going to happen at the end. This is like where we're going towards. And it's trying to motivate the students to say, with this really messy data set and this like really interesting question, you're going to be able to do this at the end when you get to the end of this case study, to try and get them over the hurdles that they're definitely going to face as they go along. Does that make sense? All right. So when you start into the motivation section, we talk about the different types of data that you can use. In this case, we introduce the concept of specifically body mass index as the way we're quantifying obesity. And there's a lot of information out there about BMIs. And so we're just trying to educate the students about BMIs. And then we talk about what are the data. So we specifically say, well, if you go to the website from the paper from Nature, there's supplementary material. That supplementary material is a PDF. That's where the data are stored. And we need to get the data into R or Python, whatever the case study is, whatever language you're using to build the case study in. So once you talk about the data, then we talk about data import, data wrangling, data exploration, data analysis, data visualization, data summary. These are the kind of buckets that we have kind of settled on in terms of a data analysis, but I don't necessarily think all case studies need all buckets. I mean, some case studies could be just a lot of data exploration. It could be building a dashboard. It could be a variety of things. But in this case, these are the buckets that we've kind of put our case studies broken down into. And then we also talk about packages. So because we're using the R programming language, we leverage the tidyverse a lot in the case studies. I think you could build case studies without the tidyverse. You could just do this in base R or Python. But for us, it's been really nice to be able to teach students about this, because then those concepts translate across case studies. So if you do if you introduce one case study in the classroom leveraging the tidyverse, when you introduce another case study, you may or may not have to introduce the concepts of those same concepts again. So data wrangling, we show it all. We kind of intentionally lead the students down the wrong path sometimes to try and make it an educational moment of, okay, well, let's try this. Like, what's the most naive thing we could try to figure this out? Well, that did not work. Let me go back and explain why that is. We try to narrate inside the case study the way a data scientist would try to narrate. You can't, of course, like anticipate everything going wrong, but we try to provide like some educational moments in the classroom. Again, making this as real and messy as you can. We talk about, in this case study, data, like distributions of data. So we talk about creating histograms and being able to measure the different types, or like be able to figure out if your data follow particular distributions. For example, we can look at QQ plots, things like that. And you can start to see we're slowly building up to that main image that I hinted at the beginning by introducing box plots stratified by time. So here we're showing you box plots for BMI between 1985 and 2017. We're introducing students the concept of GG repel and geom text repel. So being able to add states on top of box plots, how to do that. Being able to facet, so not only stratify by like one variable, but multiple variables. Again, slowly building up to this main plot, and then you finally get where you're going. And so for us, this has been a really cool project, and I thought I would give a little demo of another one to try and give you a sense, some variation. Let's see if this works. So, okay. This, do you guys see the firearm legislation? Okay, so this is a different case study called Firearm Legislation and Fatal Police Shootings in the US. The motivating figure here is again the one that we're gonna build up to at the end. The idea is to try and associate, for each state, we calculated a legislative strength score for firearm legislation, and on the y-axis, annualized rate of fatal police shootings. And so we're going to be using negative binomial regression. So we're going to be introducing the concepts of data wrangling, data exploration, and the statistic or the methodology that we're going to be introducing is negative binomial regression. And we want to be able to try and show that if the strength of firearm legislation at the state level is small, then you have it tends to have a higher rate of fatal police shootings. We are very careful to have statements inside each case study that we're not making any statements about causality. We're not making any statements that this is necessarily the right approach to use for being able to investigate this question. It's just, we want to be able to teach students data analytics skills using interesting data, but many people may disagree with the use of negative binomial regression in this setting. I'm not a policy person, and I'm not claiming ever to be. And so we're very clear about having these disclaimers in the case studies that this is really meant to demonstrate methodology and data analytics skills to be able to teach students how to analyze messy data. Yeah, so you can, we tried to make this modular in the sense that, for example, if you did not want to introduce necessarily, if you wanted to start with a clean data set, then the way that works is the instructor would basically take this R markdown and cut out the part of the lecture that they don't necessarily want to use, and they could just start with a clean data set, for example. If you just want to focus on, for example, the negative binomial aspect of it, or maybe you want to introduce more of the data wrangling aspect, or maybe you want to break it up into multiple lectures. The point being is there are a lot of databases out there with data sets, and like Google has its own search engine for data sets, but there's not a database out there of data analyses that you can use in the classroom. And so that was the niche that we're trying to address, where you can go to the Open Case Studies repository and essentially have a a repository of case studies that you can search by terms. So you can search by linear regression, t-tests, distributions, or tidyverse. I mean, so the goal is to be able to have an instructor search for a set of terms and maybe like particular applications such as public health or sports or politics, and be able to download an R Markdown that they can then build a lecture around. And the whole point is to prevent them from having to download a data set and figure out, is this data set going to actually be useful for me to demonstrate negative binomial regression? We've already gotten over that hill by providing something that we know is useful for demonstrating negative binomial regression, and they just have to adapt it to their setting the way they want. Okay, let's see. So we have, I've previously taught this way in a couple of courses, and some other examples that I just want to highlight are, like, you can do this for statistical inference for election polling. So I have built case studies where you're trying to teach students essentially statistical inference, but they don't know it's statistical inference, and you're basically trying to teach them how to estimate the fraction of individuals who are going to vote for a Republican or a Democratic candidate. They're doing inference, they just don't know it. And we do it in like a fun way. And we talk about, the last time I did this, we were talking about the 2018 elections. I've also done this with the 2016 elections. There are case studies where you're talking about distance and dimensionality direction using image data, for example. So there are lots of different ways that you can build these things. And I think that's it. It was faster than I thought.
That's great, thank you. So I think we have a good amount of time for questions or discussion with Stephanie about this project and how folks might get involved or what the future of the project looks like. So
Yes.
We're a small enough group too that I think we can just unmute ourselves and have discussion rather than raising hands or using the chat or anything like that.
I have a question about how, I guess, so is open case studies accepting contributions from others? And if somebody wanted to submit a case study, how would they go about doing that? And do you have like guidelines in terms of, I guess, like a quality control pipeline of some kind so that you can make sure all the pieces are there?
Right, so as part of this one-year project, one of our aims was to develop templates where somebody could basically start with like an empty R Markdown or a Python notebook where we have sort of like specified what the guidelines are that we would be looking for. And we haven't completed that yet. We're hoping to have that done by the end of August. That's our timeline, to be able to have this done by the end of August. And yeah, so the way we envision it would be to have somebody contact us and say that they are interested in developing a case study. We would send them the template. We could probably formalize this a little bit better by maybe saying opening up GitHub issues and having this in a more automated way. We haven't done that yet, but that's really good feedback.
I wonder too if there are specific topics or kind of data types that you'd be interested in seeing new case studies for.
Data types or topics?
Yeah.
Well, so we have an external, so as part of our one-year project from the Bloomberg American Health Initiative, we've identified an external review committee. So these are 5 faculty across the US who've agreed to look at these case studies and give us feedback on them, specifically like how they would use this in the classroom. Like that's what we're most interested in. And then how can we make this better for them? Like how can we make this so that they would be more likely to use something like this in the classroom? And then also specifically reaching out and saying what kind of topics would also be useful for you to have in your classroom. So the few faculty who are on this project in our department, they teach large public health biostats classes to undergraduates. And so that's the perspective that we are coming from right now, being able to teach undergraduates, mostly undergraduates, t-tests and like all the classic things that you would imagine a biostat student take. But that's not to mean that's like inclusive by any means. It's just that's where we're starting. I like the idea of maybe having a Google form where people could submit ideas that they would like to have case studies built around. But more importantly, I like Michaela's idea of having people contribute case studies as opposed to us doing it entirely.
Yeah, I think that's sort of what I mean is if there were, you know, if when you get that feedback, you have this sense that, oh, we're kind of missing a slice of.
We're for sure missing huge slices.
Yeah, then kind of advertising those and building groups around creating those new case studies is something that seems like it would be useful.
Oh, I'm not claiming by any means we're like
oh,
comprehensive.
No, I didn't mean that either. Yeah.
We're just like starting with a few.
Yeah, totally. Other questions?
Yeah, I just want to say thank you for that overview. And while you were talking, I was able to find nearly all the things that you were mentioned in your slides online. So it's fantastic that all of the resources are so available. Okay. And we're about to start a data science minor, mostly for art science and social science and humanities students at UW. And the kind of your open case studies looks like it's going to be just a goldmine for instructors who are looking to make their
that's the goal.
Classes.
To make the barrier as low as possible for people to be able to bring data in the classroom. Yeah.
Right. And your template, like those steps of like import, wrangling, exploration, analysis, that also seems like incredibly useful, like across any kind of discipline. I was wondering if you've documented that.
So we started we have a GitHub repo, github.com/open case studies. And there, I believe there is a GitHub that has a repository that has been started, but I would not say it's like ready for public use. It's still very much active editing going on this summer. But our plan is to have 10 case studies in the public health applications by August 31st with a template all freely available online for instructors to be able to download and use.
Great. Yes, thanks a lot. I think there'll be great interest in that, not just for me, but I know I'll be sharing it with my colleagues here at UW who are, you know, a lot of us are just looking to sort of create new classes or adapt existing classes to have more data science content for this minor. And what you guys have done just looks like it's going to make it a lot easier for us. So I really look forward to seeing that. Thank you.
I guess I'm curious too, as you expand into new fields or new types of analyses, you know, you said you have kind of a small advisory board right now, but you're mostly focused on biostats. You know, if, for example, as Ben was saying, social sciences or humanities case studies are brought in, are you then in need of a kind of group of reviewers or, you know, folks to kind of really dig in and test them out, you know, like, and how are you imagining you might spin that up, just kind of ad hoc or?
Yeah, so the answer to the question is yes, we would need experts in all of those areas. So I would basically start to identify external committee members who would be able, I don't know if you call them scientific advisories board or editors. I would have to think about formalizing that, but yes, the goal would be to expand. I'm hesitant to do that too fast though. So I would rather have like a solid set of like 10 or 20 case studies kind of built to try and like, to give people a sense of what is the project and like what are kind of the expectations of a case study. And then I would maybe, like if somebody came to me and said, I'm an expert in social sciences and it's like one particular area of like digital humanity, I mean, whatever it is, then I would maybe, and I'm interested in partnering with you, then I would be interested in like opening up an avenue where somebody could provide feedback on case studies that are submitted. I'm hesitant to do it like too fast, too broad. I would rather just make sure the content are really solid that are there. And if somebody is very interested in contributing, of course I would welcome their contributions, but I want to make sure the ones that are there are like maintained. And we're also putting we're allowing or enabling continuous integration for each one of these case studies. So they're run on Travis specifically, so you know that the code, if something breaks, we get a message right away saying that this code is no longer working, you need to fix it. So the instructor doesn't download the R Markdown as like, well, this doesn't work anymore. So we're maintaining, we're prioritizing reproducibility and maintaining that is like a big priority for us. So.
Stephanie. This is Mary Perk from Wharton.
Hi, Mary.
Hi. So I'm the executive director for Wharton Customer Analytics and AIB, or AI. It's AI for Business, and we're developing cases as well that can be used in the classroom. And I applaud you for sharing this and helping to educate everybody with it. There are so many different aspects to it, and we're at the beginning of that journey as well. We're trying to put it on an interactive platform. So I have to be frank with everyone. I can't recall how I've been invited into this call of such wonderful people, but I'm really thankful. You know how you accept these meetings, and sometimes you look and you're like, okay, what is this? And so it's just a great way to start my holiday week to connect with all of you. And may I ask who initiated this meeting and this gathering? Because I do want to give them a big thank you.
It's not me.
Oh, yeah, no, it was an ADSA thing, but we had been talking to Stephanie about the open case studies for a little bit, I think, since we heard about it at our meeting last year.
Okay, well that's fantastic. Of course, some of the cases we are putting together are more business related and such, but there is, I think, a very strong need for these types of cases in which students tackle a variety of different aspects, because as data scientists, it's just not learning how to apply the algorithm to it. It is essentially what are we trying to discover, and then really packaging that data in your data wrangling, and how you manage through that, how you do A/B testing sometimes after you have the modeling, and it's all these different aspects of it. So I'm just appreciative that you were just very transparent with where you are in the journey and how many different objectives you're trying to tackle, but at the same time stay focused within your main objective. So kudos to you.
Thanks. I would be interested in partnering with, people who are interested in partnering. As I go around and present these ideas, every time I do, I get feedback on, oh, you should think about this, or you should think about that. And I do try very hard to bring this back into the project and incorporate this. But yeah, it's an ongoing process. These are lengthy case studies to build. Some of them are short, but some of them can be quite long. And the idea is to make it very modular, where a person can really just focus on one aspect versus another aspect if they want. But you could do the whole thing if you wanted. But different people have different goals.
The only recommendation at this, we're at the beginning of the journey, that I would recommend is that I know at Wharton, we're working on a platform that can be self-serve. So, there are, my center is coming up, we ingest data sets, as part of our experiential learning. And so from those specific data sets, and when they're basically tested out in these programs, whether it's an accelerator or datathon, then we test it to say, yes, this has legs for a case. And then now we're bringing it into a platform where that's where a lot of the hard, coding and working with, the different Jupyter notebooks and the different pathways and personas within these game-like gamification of things into it. So there can be that interactive, but then it's that platform, so it can be iterative. So people like yourself can further identify those next cases. So that's more of a journey recommendation, and that's kind of where we are in it. And where we're sourcing cases, I guess, is another explanation.
I think that's great to hear that Wharton's, you have those resources. I unfortunately don't have those resources. This is just like a very grassroots effort of faculty kind of doing this on our own. The Bahi funding is really the first funding that we've received, and it's gone entirely to effort for people to build the content itself. We don't really have the resources to build an interactive platform. I guess I could approach Hopkins about that once we have like a kind of a nice repository of content. But at the moment, it's just building content and allowing people to download the R Markdowns or Python notebooks.
And who knows, maybe Hopkins already has such platforms for, it's such a large unit, I don't know, potentially.
That's a good point.
I just happen to be sitting in, you know, one of the crown jewels at Penn, which is Wharton. So there is
That's
a lot of
amazing.
resources.
Yeah, that's great.
Mary, are those case studies you're putting together at, or considering putting together at Wharton, intended to be open also, or are those going to be just sort of Wharton things?
No, they'll be open, but I mean, like anything, it's they'll be open and available to the rest of the world. But it'll be like a subscription, you know, like if you were going to buy a HBS case. So it'd be, you know, there's a nominal fee for, you know, the student to have access to the data and such. I mean, the professor will go into the platform and specify many of the things that Stephanie was talking about. Like, do I really want this to be about data wrangling, or do I want it more to be about the algorithm? Where do I really want the tension in what I'm teaching my course for? And you will choose that. Like if you really want them to, like if you want some of the Jupyter Notebook modeling already done, so they have to work more on the insight part, or they have to work on more. So you'll be able to pick and choose. Like imagine like on Amazon, you get to pick and choose what you want to put into your shopping cart. And then based on that, that'll be set up, and then you will direct the students to go and pick that case study, and they'll like download it, or they'll have their own Jupyter Notebook. You know, if we have to like, what do they call it? You know, gear up an instance of an AWS for something, they'll gear up their own individual notebook, and specific data will be put into that. And then they'll go through the case, and then the professor can guide it through a semester, through 2 sessions, you know, however they want to do it. But it will be available and open to everyone. But that's what we're attempting to do on that. But it's in its infancy. So I just wanted to kind of share that perspective.
Thank you.
And Stephanie, I had a question for you. So it sounds, and maybe you mentioned this, but I went on vacation for a second. So it sounds like you have some funding now, and the project is sort of maybe in the middle phase.
It ends at the end of August.
Okay.
Their funding ends at the end of August.
Oh, so nearing the end phase of the project. So what is the sort of sustainability aspect of this look like to you? Does it look like getting more funding, or finding a community to build around this so you can continue on more of a volunteer basis?
Right. So the way it's worked is I secured this 1-year funding, and with that came with the hire of a faculty member, and that faculty member has produced a lot of the content with some help of master students to help with a lot of like the messy data wrangling aspects of it. And then her funding will continue through the data science lab. So until other grants are secured. I can say that like we have 4 other grants that are almost like secured. We're just kind of waiting on notification of awards. So I'm not concerned at all about her funding. I'm more concerned about like finding 4 more of her, because now her effort is like, anyways, so we have to basically scale up the content development. But like this one particular award that I mentioned, it's only a 1-year project, and I was very focused on just making sure if I could produce like these 10 case studies. We have a few more that we've been working on the side that we were just interested in producing. If I can get like 10 or 15 like really solid case studies, then I would feel better going to the NIH and saying like, we've done this is a proof of principle, and we've secured letters from people who could say that they would use this in the classroom. I would feel better about that versus going to the NIH and saying, this is just an idea we have, and I don't know if it's actually going to be useful. So this funding was very helpful to try and like just build this initial 10, 15 maybe. And from there, my plan is to apply for like more sustainable funding, but I would rather go to somebody with something in hand and showing them that there is value in this and that these are being used before asking for like more funding. I guess somebody took a risk on us, and I'm very fortunate for that. I feel very thankful for that. It's a big risk, but
yeah, no, it seems like it's paid off already. So I was going to also mention that, you know, if one of the things that you wind up looking for is sort of building a community around these and kind of organizing contributions and stuff, I think ADSA would be interested in figuring out how we could help with that, because
I would love that.
Extending this out seems like a great idea.
especially, yeah, we start extending these out. I mean, I will expand these out like to other areas. It's just a matter of like who's willing to like help contribute first. That area will probably get a bigger priority if people are interested in helping narrate and edit that content first. So
great. Do we have any other comments or questions or?
I just have
Ben
one
does,
more.
yeah.
What what kind of year level are most of your examples kind of calibrated to? Like they don't look exactly suitable for first year class, but what have you got in mind for like a target audience?
So on average, I would say like an undergraduate level, but so like maybe a first or second year undergraduate course where you're learning like, I mean, it depends. So like some of the case studies, if it's just data exploration and data visualization, it's not a lot of statistical knowledge that's assumed. If you're demonstrating like the use of packages for data visualization, I would argue like maybe even a high schooler could probably use that content, but it depends on what you're interested in incorporating in the classroom. Like even if a case study does assume that you have some kind of statistics, if you just focus on the wrangling portion, then it could be targeted, like your lecture could be targeted for a different level. In the README, where our goal is for every README file in the repository to have information that we perceive to be maybe useful to the educator, such as we think this will be useful for a first or second year undergraduate course in public health or whatever. And we anticipate this, if you taught the whole thing, it would take 3 lectures or 3 hours. And these are the types of breakpoints that you could consider using the different portions of the lecture. These are the keywords that you could search for and things like that. We're going to put all that in the README. And then we're also building a website where you have like essentially a searchable table that you can quickly type in search terms and figure out like if there's a case study that exists for something that you're interested in.
That's fantastic. Thanks very much.
Sounds great. Stephanie, any additional pearls of wisdom you'd like to leave us with?
I just encourage all the educators on the call to bring more data into the classroom and to put the problem first. So whenever I was taught statistics and data science, I was never really taught, like linear regression, I was never really taught to put the problem first. It was just somebody going to the board and saying, y is equal to x beta plus epsilon, and now we're gonna like derive the estimates of beta, and like what's x, what's y, why is there an error term, like motivate it with like, here's a plot of x and y, and I want to measure the strength of that association, and there's this thing called linear regression, let me tell you about regression. So I just encourage you to bring in the problem first whenever you're teaching students data science, and then always bring in data as early as you can. I find when students have their hands on data in the classroom, they have a better sense of what's going on as opposed to like having a lab that's separate from what's going on in the classroom, because then you have to make the connection of what happened in the classroom to the lab as opposed to just like it happening simultaneously. So those would be my pieces of advice.
Wonderful. So we're probably running up on time, unless there are some additional questions. I just want to remind everyone that there are some additional resources in that document that I shared, but I'll share it again right now in the chat. And so there are resources here related to the topic today, but also resources there about ADSA and how you can get involved with the work that we're doing too. So I'd like to thank Stephanie again for hopping in today for this presentation. It's a really cool project and we're excited to hear about it and see where it goes.
Thank you, everyone.
Thanks, Stephanie. That was great.
I really appreciated the platform.
Awesome.
Thank you so much. It was great. It's nice to meet you all too.
Nice to meet you.